Okay. You wondering what you have to do on W5.5? I'm going to tell you. Let's go. Question here. They're talking about the force due to gravity. They gave it at 5 different locations. A, B, C, D, E. And so, these are distances from the center of the Earth. Fine. Determine the mass of the object. Well, this is the object they're talking about up here. So there are, in fact, 2 masses. Mass number 1, object. Mass number 2, what is it above? Earth. Those are your 2 objects. So we have mass 1, that we need to find out. Mass 2 is the mass of the Earth. You can look that up on the reference table. Of course, you know G, and then you are looking for, let's see, this mass, and you have 2 other givens. You have R and you have FG that go with this equation. Now, how could you possibly connect these? Do you know them both? Well, if you choose any of the positions, A, B, C, D, or E, they give you both an R and an FG. So it doesn't actually matter which one you pick. Just make sure your givens coordinate. Meaning if you choose this FG, 1,000 newtons, you better pick the R that goes with it. If you pick this FG, you better pick the R that goes with it. And so there you will have 1, 2, 3, 4 givens. You'll find the 5th, the mass. That brings you down to question 2. Question 2 says, at what distance from the center, we call that R, does the object, that's the same object from up here, since you already found its mass, you know the mass now of that object, experience a gravitational force of 28 newtons. Noticing we have R, we have M, we have FG, of course you can do G. We're going to need a second mass. What is that second mass? The other object that's involved? The Earth. Again, you know its mass, so you can run your numbers between here. Good. That should be probably the most conceptually bothersome set of questions on this homework. Otherwise, just plug them in, watch out for units, watch out for prefixes. Then, over here on the back, in the notes, question 41, we determine the gravitational force exerted by the Earth on the Moon. Just in case your class ran short on this question, we did question 40. In question 40, we figured out the gravitational force not of the Earth on the Moon, but of the Moon on the Earth. And it came out to 1.99 times 10 to the 20th. Question 41, in case you missed it, asked for the gravitational force of the Earth on the Moon. And in fact, we did no calculations to solve this. We did none because the givens are exactly the same. The mass of the Moon, the mass of the Earth, the distance between them, and G. So this also comes out to exactly 1.99 times 10 to the 20th. That's your question 41. And that, we'll go in here, question 6. You're going to use that to help figure out the speed at which the Moon orbits the Earth. So if you need a little hint here, circular orbit. If it is a circular orbit, yes, here's the Earth, here's the Moon. There is a center-seeking force. That center-seeking force is the force due to gravity. Well, we know the force due to gravity, and so you know the FC. And if we know the FC, we can turn this into a speed. We have an equation with FC and speed. Do it. Otherwise, you should be good to go. It's an H question. Do it on a separate paper. That's it.
Shout out to me!